Is it live now? Oh, it is. Wait a minute. Oh, okay. There we go. We have solved the issue. I don't know what it is, but it has been solved. I'll take that. Okay, wait, let me quickly put this on the screen for like 2 seconds for the automatic. For like the automatic YouTube thumbnail thing. Should be long enough. Oh wait, there is an error in YouTube. Okay, I can see it now. Oh, it's having like issues with the rate limit. Then I'm streaming too much data and it's complaining about that. I need to probably like lower the bit rate or something. I'll look at that after the stream. But this time it did accept the broadcast, so I'll just roll with it. And I'll fix it later. Let's see. Good enough. Okay, so I'm not exactly sure if this is going to be useful at all. As you can, if you saw the like 4-minute stream I just attempted, my NVIDIA driver crashed, so if I'm disconnecting again, that is probably the reason. I should probably stream on one GPU and do the rest of my PC's work on the other. But right now that's not my setup. So I was looking at I was going through like a first iteration of Chyp yesterday. And I was like seeing a lot of duplicate code, but also at the same time noticing that this formulation I'm working on is really native to this kind of thing it wants to do. So I'll have to do a lot of passes over them, so that I'm probably just going to work on that, and if there's someone else who has a question at some point, that will probably make the stream interesting. But yeah, the progress you can just find on the on this GitHub here. It's not that interesting just yet. Let's see. But I guess an example of why this thing is so useful is, let's see if the streams. I'll just leave the streams after I know it's definitely working. Good enough. I'll delete the YouTube chat open because that one is currently not synced. So when I'm trying to say that two things compose, or at least the some of the code in Chyp is trying to do that, is what it's basically saying. So there was this, I'm not sure, did I remove it yet? Alright, so I don't know what I did there. So this code, which tries to compose like two hypergraphs or two hyper edges, it's using Python itself in order to do that matching. And what I'm trying to do is I'm trying to build up this kind of functionality within the structure while I'm building it, which is a bit more unusual, but I'm noticing why it's so useful. So basically what I'm trying to do is this. Say I have like 4 points on the one side, which is supposed to be Is this going to work? Oh, the other side. So you have 4 points on the other on one side, which is supposed to represent like 4 incoming edges. Wait, I can actually put that on there. It could be 4 things if I want to compose them, but what I'm actually trying to get at is, let's see. And I need to move them a little bit to the left. To the left, wait. Just up. Okay. Okay, say I have these 4 points. These are representing like the 4 incoming, or 4 inputs, or 4 outputs, or something. So say these are the 4 inputs. Maybe I'll quickly like get the, where's this thing? Paper from Chyp. So it's basically trying to, I guess one way of phrasing what I'm doing now is like trying to compose like these, when you have like one function here, one function there, and you want to compose the inputs and outputs, so just connect them together. You want to get the output from one side, inputs from the other side, and just stitch them together. So in order to phrase this in this structure, say you have like 4 outputs from one function and 4 inputs from another function. Let's see. I want like this. This is not red. What is red? This is red. So if like 4 inputs on one side, 4 outputs on the other side, what I basically want to do is like stitch them together 1 to 1. So the upper one to this upper one, etc. But one way of phrasing is that while you're doing this, so the thing that's actually composing, what's the like, quick way to do this? So okay, wait, I'll do it like this. That is definitely not what I wanted to do. Bottom. Same for the other side. Like one way of phrasing it is that the thing that's trying to compose these two already has access to both those things. So let me actually move this thing down so it's not entirely confusing. So the thing that's trying to compose them already has access to both lines. So it can like already traverse the left side, it can already traverse the right side. And it's the only thing it's trying to do is like travel up to this one, snatch the connection to the rest of them, and connect it to that. Then go to the next one, snatch the connection, connect it to that. Go to the next one, snatch the connection, connect it to that, and just keep doing that until they're all like connected. And you can like set up checks to ensure that there's like the same count on both sides. So that's what the code here is also doing. There are some efficient ways to implement it, but that's the essence of it, as in it's not really more than that. So there's probably a way of doing this, which is like a very simple structure, which is traveling like across this yellow line constructed through this. So the only thing it's actually doing is it walks all the way up here, takes this connection, destroys it, and moves it along. Or things like that. I'm not sure what the actual implementation eventually will be. That's, I guess, a very simple way of trying to do this. Or if you're doing it visually, you can just do this. Let's see. I think this will work. Then just... do I need to remove these ones, right? Nope. But this is actually what you end up at some point. So all the outputs and inputs are like connected to each other. So this code, is in the way it's phrasing this compose here, is if we go back to this one. Nope, definitely not that. Very interesting things. That one. So it's like doing a lot of this stuff by hand. So all the matching of left side, right side, which is just some very symmetrical structure. It's like trying to go through it all by hand. And this is definitely not... As in, what I'm trying to do is use the existing structure to say the inputs and outputs are the same thing as saying... if you have some hyperedge, which connects like a lot of things on the left side to a lot of things on the right side, that is already like saying it could be a hypergraph, as in you can already interpret it as a hypergraph. Or you can already interpret as inputs and outputs. So the only thing you're actually doing here is just composing hyper edges. Composing hyper edges and then just destroying the fact that they're hyper edges. Let me like copy paste this so I can quickly switch between the two. This one, this one. That do. And then where? So this is basically what composing hyper edges or hypergraphs is going from this structure to this structure. And that's basically all it's saying. So there's a way of doing this in saying, say you have this thing again, is just actually interpreting this as another one of these rays. So instead of what it's doing here, it's going through like all the outputs, all the inputs, getting the codomains, all the things to the left here, so what these points are, and all the things here to the right as domains, or the other way around, I'm not sure. Doesn't really matter. It's but if you, while you're already implementing this, there's a way of phrasing it in the same structure, which I'm doing here. So you have like a left graph or right graph or edge, and you're just like putting that in another one of the structure of arrays of array. And then the idea being that you can like recursively compose until you have like a very simple structure, which then which doesn't need to compose again, and then you can just collapse the entire recursive stack. Probably doesn't make much sense now. It's pretty much, it will make a lot more sense once it's actually implemented, but I'll quickly work on that. I'll be right back. 1 sec. There is definitely a way of phrasing this with a very, very simple, very local structure, which is as if it's like a very small creature, just walking up here, taking one, putting it here, taking one, putting up here. There's probably a very simple way of implementing like what composing is. Recursively like that. I'm not sure if anyone has done it before. It's like a very intuitive, a very easy question to ask in this setting. And then once it's actually implemented, I can make an actual good version. All right. Let's see. Let's actually implement this thing. I'm not sure if. Okay. I might like do that actual implementation later and now just do a very simple copy as I've been doing with the rest of this so far. I'm basically going through the whole code and just doing a very simple translation, and then I'm hoping to iterate on it, because this is definitely not going to be the final implementation. Do I? So it's doing like checks here. I've already noted this somewhere else. is in a lot of this code, it's like constantly checking for type size, which is just the same thing as what it's actually trying to implement. Just trying to find equivalences on some type of structure. So all these kinds of equivalences can be done similarly in the same structure. You don't actually need to implement it. But you have a particular way of like phrasing a very simple equivalence between two things, which doesn't need to be completely accurate. You don't need all these things. They're already implemented in the implementation. Oh wait, it didn't actually update on Twitch. That is a bit odd. Oh wait, it's up here. Nice. Should be a way to change the topic. See, now Twitch might go to a different title. Nope. I mean, YouTube has the right title, right? Yeah, it does. Definitely not going smooth, but who cares? It's doing all this stuff by hand to calculate the coordinates. It should definitely be doing that automatically. Should be something like this max here is something we can like generally implement for each ray, as long as there's a conversion to a particular kind of structure. Not sure yet. I'm not sure on which level you want to implement this. That's a good question. Which level do you want to like implement min-max here? So the x and y coordinates, which Chyp is maybe I should go with Chyp as a reference. Where can I just install it? Can I just do Python Chyp? Where are you? Where are you? Oh, maybe like this. There we go. Doesn't really matter which one. Oh, it's actually not this one. So the reason why because it has all these constructions of types and other things it's internally trying to manipulate, which aren't using the fact that the structure itself can already do that. Let's see. What's a good place to put this thing? So the place where it's like drawing these boxes. Let's see if I can get a bit different example. Doesn't really matter which one. But there's like a very simple data structure, which is where the edges and vertices are. And the x and y coordinate are like manually implemented in them. You could still do something like that within this structure. but you would probably like phrase the numbers of what the x and y actually are as just more of this. So it's basically when it's trying to compose here, it has this structure. But on each of these points, so the inputs and the outputs of one end, or the other way around, these are the outputs, these are the inputs. It has like an x and y coordinate on where it is on the screen on each of these points. It has, what else does it have? It has a data type, or whether or not it's like an integer or a string which is contained in that thing, which again you could just phrase as more structure. And it has a size. What does the size mean again? Like how many there are in there, which is just similarly whether or not there's actually more defined here. Is that the case? What is the size? Oh, maybe the size is like on this line. So these are the inputs, these are the outputs, and the size is like how many there are in there. How do I like generally implement a min-max function? That is a bit of an odd question. Maybe like I'm not entirely sure yet. I should hold YouTube open. Is there a way to like only show the chat on YouTube? Probably is. Hmm. Just using. So I have like a line of numbers. What does min-max mean? Min-max means it can like look into each of the points. And it has a way of like sorting them. So just a predefined order, which it will find back through some way. Bit tricky. I mean, I'll just put it on. I'll just put it on implemented on the main one. Just figure it out later. So basically, whenever you have, if you have a number which is defined in bits, and you're on the line which defines the bits. So you have something like, I need a way to do this quicker. Let's see. He wanted to just describe a 4-bit number. See, I need a bit here. Just do it like this. I think. Wait, I'm just doing it over here. This is definitely not great yet. Oh, that is definitely not what it's supposed to be. Because it's like nested structure. Okay, wait, this is not good. I'll just grab the other thing. I need to get this interface working ASAP. I do not want to work in this. I'm constantly going back to React. Let's see. Did you have one of these lines? Which just has like a number of bits defined on it. If you're asking on the yellow line, what does min or max mean? You're basically asking whether, I guess if these are like higher numbers or like more complicated structures, it's not as obvious to answer that question. But in general, you can define a min-max for each ray. If there are multiple options, if there's 0 options, depends on what you want the min-max to do. But in general, it's just always defined on here. That's probably the case for every function. It's not necessarily obvious how to implement it for every function. Yeah, so min-max on like one of these numbers is like the x coordinates, and it's trying to like get the largest one, where largest needs, you need something else to say what the largest is. Like in this simple case of like 2 possible options, it's just the terminal end, so like the last one. Or in the case of a directed graph, it's like the last element. Much more harder to say that in general, which is always the case. Okay. Basically, how you actually want to implement this at some point. So definitely shouldn't be here, but let's assume for now that it is. Basically want to say, take the vertices, take the x coordinates of all of them. I have not yet implemented this. But if it's a list of something which you want to like call x value on each of them, it should just be implementable as this. So then turns your list of axes. You just come in. Or x in this case. And you do the same for the edges. And then you do the same for this thing. The x, of course. This is why it's harder in general, because we could define like this max here as well by default. Not sure yet. Wait, it's an interesting question. Can you like recursively do this to the smallest number? Okay, wait. What if a way of by default implementing this is like always to recursively go inside every single structure? If you have a 32-bit defined, you take the max from within there, what does it give you? Like a 1 or 0. If you recursively do that for 2, just gives you 1 or 0. It doesn't give you back the actual number, so you can't actually recursively. Is it max self, max other? Oh, because it's doing it for both. Yeah, so it's still saying this dot vertices, because we're just using the same structure. So what it wants to do is this. And if you just translate it to 1, it's like vertices, vertices edges, and then The minimum value. What is the minimum value? Oh, it's just going to get bounds. This should definitely not be on the compose function. Like, I get why it is. It should not be here. It's trying to reason from within the visual structure first. It's like limiting. Doesn't help with the code. So what we want to do is min max. Min is outputs. I mean, the vertices and edges are like automatically already incorporated. We need to think about them. So it's just trying to. So we have the terminal. So we have this red line now. The compose is like the yellow one, terminal is right, initial is left. We want to, from all these, get like the x value, so where it is on the screen. And why min? It doesn't matter which one we take the minimum of. No, we'll find out later. Get the minimum of those. By calling x on each of these. X, it's just recursive, iteratively getting a value for each of them. So you can probably see it as you're just drawing 4 lines through all of these 4 points. And all 4 lines add up at different x values. This is min other. You can probably generalize this to like a function on both sides, on which on either side you want like 2 extremes, so min and max. Not sure how you would call that though. So min. This is an interesting question. But there's probably a general way of phrasing. Okay, take anything. So take like the yellow thing. Then on the left side, do one particular function on each of the points. And on the right side, do the opposite of that function on each of those points. So in this case, take this one, do max on everyone, take this one, do min on everyone. So probably what it is you give me like a function to execute, which in this case is something which on the initial end has min, something in the middle which is just the function itself, doesn't really matter. And then on the other side is max. And when you apply this in reverse to compose, it gives you this. Oh. Should probably look up if there's a name for that. There probably is. Hmm. Mhm. Yeah, this is like very hard to intuitively get without like a visual like this. You need to do so much gymnastics. Um, these edges. What is this used for, by the way? Is it used for anything? So the internal side. It's input, which is other. Hmm. It has a default. Why would you need a default for min-max if there's no result? So whenever you apply a function and there's nothing found, then you want a default. Yeah. Default is what you do in the case of the fact that there's nothing. Um, plus defaults, case of initial terminal is option. To which the default sometimes is nothing. Case of max 0. So there's a way of phrasing that in a particular way these are like opposite extremes. It's not necessarily obvious how you say that. Sure. I should definitely find out if someone has a name for this. Because these are like tied together in some way. So min max. It's just an array of these two. It's iffy. I mean, what is it basically saying? You want to apply a function which is possibly either not necessarily reversible, but you have an opposite in some way. To this. So basically you have an array, just a function. When you apply that function, you apply the initial side to this initial side, the terminal side to this terminal side, maybe. I don't know. We'll find out. You might even want to nest like stuff inside there. So the text. This is very confusing. I'll probably go back to this. Because it's hard because you want to chain the min-max after the x, but still hold the fact that there is terminal initial here. Only way to like very beautifully phrase this. Just ignore that for now. And just make a simple implementation here. So min-max. X-max. Would the vertices and edges be different? But that's like saying that anything here is that this point is like up here. Okay, that's not covered yet. Entire structure. So I need to like recursively look through it. So at this point, it's like up here. Then just checking here is not enough. You need to traverse this, check if there's anything higher, min that, min that, min. Just keep collapsing it until it's back here. Shift all vertices and edges of this graph below the x-axis. Why is that doing actually? So this is just saying that the post initial these are the vertices. It wants to like go through all those. and say, oh, I wish I could overload. Maybe I'll just go to another language. Make it pretty. It's again like cursively going through everything. So in this case, the output side. So it's like taking all the x values of this, and it's subtracting the x value. So here, just moving it down. It's moving this to here, this to further down. Copy the vertices and edges of the other graph to this one, with all vertices and edges shifted above the x-axis. So it's just like visually separating them. And then connecting the dots and then reordering or something. So it's like putting the blue one on the bottom side of this yellow. Wait, let me actually do that. Position. I don't know if this is enough. Okay. But basically move the outputs down visually. Then it's like saying, okay, assume like this visual is the actual graph. It's bringing the red ones into display. And then it wants to connect the dots. And then I'm guessing that once it has connected like the dots, then it allows some algorithm, which I saw somewhere else, like resort them. The first season edges. I'll group to this. So another is like the lowest one there. Yeah. This is what it's doing. What is this VMap? This VMap is temporary swap or something. Looks like it. Don't use here. Like it's basically moving to another graph, just stuffing it all in there. Yeah, so instead of like operating in this graph itself, it's just copying and then moving, stitching them together, destroying the things it doesn't need. Things like that. Okay, so it's just copying the edges, the vertices, right? How would I translate this? I don't actually need all these. Why is it doing all this? So it's basically copying. So it's assuming that you don't have the yellow line. So you think the yellow line away. It's just assuming that these two graphs don't know about each other. They have their own x values, their own position in their graphs. It wants to copy them. So basically what it's doing first, it's first copying them, moving them to this structure, which is completely different, just a complete copy. Then it moves the red one to the position where it is now, instead of wherever it was. Okay, wait, it's not taking them separate. This is what it's doing. It has them separate. It has them separate. Then it translates the blue one to another position in the blue one, so the blue one is just changed. Then it translates the yellow one, or the yellow, the red one to positions here. So instead of positions here or whatever, it's translating it to the, it's copying the red graph to the graph of the blue one, like this. And now they're connected. And only then is it adding together. But this is definitely not general in the sense you could also say you wanted to copy the blue one first and then do this. Which it did like before. So if you like right shift, it's composing, but first it's copying it. So that's what you're doing here. So at least, yeah, so this is basically what I was saying here. I was expecting this copy to happen here. So when it's right shifting, it's giving me some graph and it's copying it here. But you could move that copy like outside and allow it to completely modify this graph. Because you don't want this copying, you want to abstract the copying away from this. How do I do this now? I'm just going to ignore the fact that it's copying. But basically what it's doing, it's saying it takes the inputs, takes the red one, and basically moves it to a location where it looks like this. So it just moves the red one down to the top level of the blue one, and the blue one is there. I think this is what it's doing. Okay, so when we're at this point, we basically have a graph that looks like this. Wait. Oh, okay. Yeah. I don't actually need to. Okay, this is much clearer. So this is basically what it's doing. It's moving the left side to like a negative. As if this is the Z0 axis, yellow one. It's moving the left side to a negative place, and it's moving, or it's ensuring that the inputs on the right side, if they're like elevated above this yellow line, over this line here, it's moving them down. It's much clearer. Basically seeing the composed line as x is 0, and then moving outputs left to -0, -x, and moving the inputs right to +x. So I've now separated them like in y as well, but this is not the case. So it could be the red one could be here as well, but that's not relevant for now. Okay, the rest is just a copy. It's putting them in this one. Copy. Okay, wait, it's putting the sources. Let's remove it right now, right? I think so. Yeah. Plug the two graphs together. In other words, merge the input vertices on other inputs to corresponding output vertices of cell. Now it's checking the length again. Why is it checking the length again? It's checking the length again because it did the copy. Yeah, because it's moving them to this like copied VMap here. It's like checking whether the length is the same, which is just a check. Just check in the check code. It's just done after the terminal.copy. We implemented it. Like a way of phrasing this is it wants to copy wherever it finds the red one, it wants to copy it from where it finds it. And just assume it's completely different than whatever other structure the red one is attached to. But like only wants to consider this part of the structure. If there's additional structure on like connected here, it doesn't really care about that. This could just be removed code. So the plug 1 and plug 2 are basically already here. They're just the initial side. Just the outputs and the inputs. Just a dirty copy. What else here? We don't need to open video. So it's setting the outputs, the inputs. Change will keep track of which will. This is probably like we can implement this much better. Huh. Where is it storing this? Merge vertices. Great. It's basically a reference type check. So basically just checking whether on the left or right there's the same kind of thing, ignoring certain things, if there are certain things relevant. So in this case, the relevant things are data type, whether whatever structure is expected to be there is actually there, whether they're big in it. Structure. Basically just another equivalence. So plug 1 and 2 we already have. It's doing like a very dirty merge, which is using this code. Which is just drawing these equivalences. Like making sure that this one is connected to that one, etc. What is done with this history? Resulting plug 1 and plug 2 are not the same vertex. Oh, okay, so it's basically just using that to differentiate between things that it's plugging itself into. Hmm. Like not. Hmm. I'm not sure about this one. Again, checking equivalences. Hmm. Damn. I think I should probably go back to the the edge and vertex data structure. Try to abstract that away first. Hmm. In the season where this vertex occurs in the input and output. Yeah. So this should basically be a reference to like another structure which is using like a particular in and output as like the beginning of a function. Hmm. And then the in and out edges I mean, they're pretty much the same thing. So on one level, the in and out edges are like continuations of some line or of some function, like inside the hypergraph. And it's at the level of the hypergraph, you're saying in and outputs, which is just a way of saying that the graph and the edge are just the same thing. But the graph is less detailed or just another level of description. That's a way of phrasing it. Where are these even used? We're using... Okay, so these... I should probably like work on visualizations first. This is starting to be a bit hard to keep track of. Okay, let's do that. So graph is basically, in this case, it's just two things, edges and vertices. So it's just two size array. First one being another array to vertices, the second one being array to edges. Okay, I'm going to visualize. Problem is that this is error filled. What is a good way? Just to work on another branch, maybe. It's a bit iffy. Should probably work on another branch for visualizations. Hmm. This is never going to be needed. No, just leave it there until I have the solution. This insert ID after thing is just, it needs to go to some place that needs to be something general. And there you want to do something, and that's the only thing that needs to be implemented. Tensor. Maybe I should like take a quick look at Tensor. I'm guessing it's going to be a lot like Compose. Let's see. Monoidal product. Like this thing, like whether or not to do it in place or on a copy or something, should not be implemented on functions. Layout if true. Compute the new y coordinates. Also not something that should be here. Put it away later. Mhm. Mapping used to match. Yeah, here. It wants to do it in place, but it uses a copy. Like the same thing again. Like either make the copy and do it in the copy, return the copy. Definitely not. I mean, the whole thing with Chyp is probably that it's a like proof of concept in order to like bootstrap other projects. Why this is probably expected. Hmm. Use on computer. Okay, so here it's doing the same thing with for y coordinates. Let's start with this again. Um, is this it? Did I miss some structure? Let me quickly go to the main GitHub. Graph. Am I missing something? This is just not implemented. Where's this used? That's why I'm confused. Because it's just the same thing. It's just the same thing on another level of description. Okay, that makes a lot of sense. Inputs and outputs. Okay, so I can probably like these. It makes a lot of sense. That makes a lot of sense. Like depending on how much additional structure is defined that a product is just compose. If I'm not missing something, then it makes a lot of sense. And that speaks to the power of this formulation, if it is. So it's like doing max self, min other again, but then with y. And it's working again. I can just, it's small enough that I'll just copy paste it for now. It's doing the exact same thing, but then using y instead. Then it's doing a copy again, changing the y coordinate. And then it's setting the in and outputs based on this. It's always like saying that the vertical, it's only doing it for graph. Does that mean is it setting inputs and outputs compared to outputs only? So it's setting the current inputs to the other output. Oh no, it's adding. Oh wait, okay, wait. Okay, now it makes a lot more sense. Hmm. Oh. So if I have two of these, like with inputs and outputs, it's like connecting all the inputs to one side, all the outputs to the other side. That makes a lot of sense. Because it's just placing them above each other. So two copies of this. So it is like composing, but then on another direction. The composing part isn't like actually implemented here. Okay, that makes a lot more sense. Just subtracting these. Same thing. It's like it's doing +1. Okay. So it's like this. Okay, so the previous one was X like this, now it's Y like this, same principle. Let's be this. Right, let me double check. It's different. So with compose, it's using inputs and outputs. And with tensor, it's only looking at the vertices and edges of one. It's not actually looking at the output, but it is looking at the I mean, it's just the same thing. So I'm missing like a small part here. And then it's pretty much the same. Okay, so the tensor is pretty much the same thing as compose. The only thing that's different is that it's like taking this equivalence and it's actually like ignoring it, as in it's adding this structure to this structure. And with compose, it's actually trying to like destroy this line, this line, this line, and then connect them all. Okay, so I need to the minimax be on vertice edges, not necessarily on outputs, inputs. And then it's the same thing here. Let's see. I mean, that makes tensors like really inexpensive to implement. Once it's actually implemented. Because in order to like implement a tensor, the only thing you need to do is to let's see if I'm saying this correctly. You need to do a copy and then draw 3 equivalences, or just 3 places where you say reference this other part. And then you have a tensor. I definitely need to look back at this at some point. How you actually get it to the hardware at some point, it's not necessarily obvious just yet. But at least abstractly implementing a tensor is really nice. Okay. And this is just the only thing we need to do is add equivalence or reference on the like input-output extremes. So basically we're taking 2 copies of this and we want to tensor them. Basically what we're doing is we're just connecting both blue ones and both red ones. And then we have tensor. Yeah, so just doubling. Copy, doubling. Well, not really doubling, depends on the other graph. When I actually implement this, I should probably look at TinyGrid as well. Because there I probably have some implementation. Like details I should look at. Oh, okay. So they're not the same, but they're really, really similar. Okay, I should work on the visualization now. Now that I know that the tensor is also like really easy to implement, it's enough for me. Okay, I will do visualizations in another branch. Let's see. Wait, I can just do this. Can I just branch from one of these commits? From this one? I'm not sure if they've like implemented this in the interface. Don't see something obvious. Interesting. I would have expected like a button here to say like branch from here. I'll just like go from the main branch. Okay, I will go from the main branch. Let's see. Probably just have to like copy 1 or 2 things. Face. Which means I can shut you down. I'll just copy over some files, it's much easier. So slow, I really need to like move the stream to 1 GPU. It's using some CPU as well, which is not good. PC is definitely slower now. Wait, what? Oh, it makes a lot of sense. I'm just gonna copy. Wait, is there a way to like take the branch? Like, which branch do I want? I want this one. Is this a merge or is it a rebase? Okay, there you go. Please. I thought that would have done it. I'll just branch off here. These. No, from here, reset to the left. I'm definitely doing something wrong. I have not used Git like this before. Doing nothing. Okay, I'll just work in another. Okay, let's just do it like this because I can't figure it out. Let's see. All right. So what I'm going to do now is I'm going to try to build up the arrays just from like key bindings, left, right, like automatically expand the graph by just going left, right on keys, that sort of thing. And then once I have something in place, I can like hook Chyp structure into that. Then I should be able to like test a bit more easily. Because right now I definitely cannot. That is a good way of doing this. Let's push it to oh, I need to make a change. That's really annoying. Here, a change. All right. Like Is this like visible on stream? My camera's under here, just a bit. There, beautiful. All right. Wait, I need to like make sure I'm not overriding Chyp key bindings. There are some in here somewhere. Okay, it's like only control key binds, no F4, undo, redo. It's like Control C, Control, or Control Z, Control Y. Okay, they do not have normal key bindings yet. Okay, so I need a way to manage context. I mean, it will probably like it will definitely not eventually end up in React. It's probably just easy to set up this way. Because React is definitely going to bite me in the ass at some point. I have like a very simple example somewhere. There we go. I need to like implement option in array as well. Like it's just another boolean. How would I do this? Like whenever there's this expected, you just have two possible values. Do it. Okay, be right back. Like for now, probably using React will probably be fine. Okay. I definitely need to like put option in array as well. There's no reason why it should be implemented in JavaScript. The option should be an abstraction layer, so I can use option from JavaScript. But it should still be array. Okay, I'll just ignore that for now. Just work with the setup I have now. So, the simplest thing we can do is something like only growing the graph left-right based on the position you're in now. Have multiple positions selected at the same time. And movement. So like arrow keys for movement, control arrow keys for growth. Something simple like that. Let's see. I'm trying to think of what the best way is to implement this first. It's definitely going to change. I just need to get a feeling for what like good things are. Okay, we definitely need to render the whole thing, so let's Hmm. We will just move option into whatever array is at some point. No. It's giving me an error. So do I want to render based on the selection? Probably. One of the ways I could do this is like have the graph structure separate from me pointing at the graph structure. But they should probably be the same thing. So when I have like this position in the middle selected, it should render based off that. Yeah, it should always render based on my selection. And then at some point you can have like optimizations to render it not necessarily based on where you have your cursor. Okay. That's definitely not better. I mean, I could probably still put that in at some point. Center thing will be removed at some point as well. Like, you always start single point. When you like move to the right, I mean, the hotkeys should also be implemented in race at some point. Oh yeah, I also wrote that here. This is definitely not pretty. I'll just use this setup for now. Just improve it sometime. It's just like this is a vertex. What happens if I just do a vertex? This is where having a react here is a bit tricky. Because like there's like arbitrary structure in there. We don't necessarily know whenever we're continuing or following the continuation of a line whether or not there's either something there. Like usually when you have a screen, you can assume that all the pixels are a particular size. In this case, it's not necessarily true. You can probably grow with... Do you want to grow or move with control? Which one is more natural? Like control, probably. Is it control? I'm not sure. Shift. Shift works. Yeah, what is a good way to solve this generally? Okay. Just going to ignore the fact that we have reacted all for now. Just whenever something is pressed, I'm just going to recalculate. Or like calculate all the positions of where everything should be based on the relative structure. So just leave it like this. So if the first one has position, I had like a dirty way of like doing this for now, right? Dirty store. So whenever I'm putting like values in a vertex, like it's at this position, or it's like X or Y coordinate is this other thing. It should be rephrased as more race, more structure at each point. But for now, while it's not actually implemented, I'll just have this simple thing. I have something. Like I can put things. I'm not sure what the right place is to do this. It's definitely still a bit hacky. Um. Oh, other key binding. So not you. Hmm. Um. I'll just do a method here for now. Um. Something simple like this. Options. So we want like the first ray to always be in the middle. And then when we move to the right, we grow one to the right of it. So in this case, it would be like saying this thing as a reference, if its position. Must be like a setter or something. Oh no. Because I want this to return array. Okay, wait. It's a bit iffy. Can't really do that in JavaScript or TypeScript. Can you? I don't think so. It's complaining. So I basically want probably just implement it like this for now. And just move it to the right. Still a bit hacky, but it's good enough. Is it too slow? Did I make like an infinite loop somewhere? Maybe it's just definitely slow either way, but it wouldn't be this bad. Oh, well, that makes a lot of sense because I'm not actually rendering anything. Hmm. Okay, wait. Um, um, I mean, I don't even need selection here even. I can just do something like this. Selection here and then... Okay, I will separate them for a moment. Just these. Let's see. And then just take the render options. Why are you complaining? Huh. It's really, really slow. Okay, I should definitely check at this off stream. So boom, boom, boom. Okay, so when we're this is basically our cursor. It's just some key state for now. Doesn't even matter. Don't even need to continue it with. That's just what I want it to be eventually. I just need it. With some structure. Why is the PC complaining so much? Why don't you work? Am I setting like the hotkey somewhere else? Might be. Let's see. I'm not using you now though. Too many active WebGL context. Okay, that might be why it's so slow. What's wrong? Is it struggling? Maybe because there's nothing in here. Mm. Should be there. Let's see. Why aren't you working? Oh, because I've set it up like shift. Huh. Okay. I'm just gonna remove shift for now. There's definitely something really wrong in the code somewhere. Like on each render, it's making a new WebGL context, and it's definitely not having fun. That's React for you. Okay. So this thing is like undefined. Okay, I'll just. So the only thing I will need to do is this in a bit. There's really something wrong with WebGL. I need to figure this out. Maybe because on like the hotkey press, it re-renders. Okay, I will probably need to like separate this into a separate component, otherwise React is complaining. Like, I don't know. Interface context. Just interface. And just move all that here. Oh, you love me now, React. There we go. Okay. Yeah. So what was wrong there is on every key press, it was like re-rendering the component, and because this like React component here is initializing the WebGL through 3JS, it was like, I'm not sure if it's a kernel, but it's like constantly like calling to the GPU, which it shouldn't be doing. Like 60 frames per second, not great. This way React knows, okay, this is a separate context, and whenever this changes, this doesn't need to change. So it's not re-rendering this every single time. Okay, and now it's just a question of, if I'm not mistaken. There we go. The skill. I need some default values here. This should be 20. And I could like set the selection to next. Or I'm not sure. I don't need to manage the context just yet. Like this should all be done automatically. What I'm doing now is just hacky. Wait, it's this. Why is this position? Is it because it needs to be 60? 40 then. Halfway. I'm going to like put the default scale. Default scale 1.5. Here. Scale there. Now maybe the 40 needs to change to 60 again. I don't know. That doesn't look right. Why isn't the scale transferred? Like the first one is like small for some reason. And then it like works. That's really weird. Why is this first one not working? Oh wait. Oh, that makes a lot of sense. It's not on the reference. Very nice. Okay. Very slowly. You're making the interface work. Okay, I need to like interval I 20 times skill 20 20 no, it's 40 times 2. There we go. Okay, so now we can just scale down and it'll still work. Okay, now based on our selection, I want to do this. So to showcase whatever we have selected. Okay, this probably should be better because you can select arbitrarily many things. Using do it on the position, rotate it. Like at a weird angle. I mean, I could also change the color if it's selected. That may be better. I'll just do this for now. Could change the color. I keep forgetting what red is. This is. That is red. And we can like track whatever we have selected, and whenever I hit the right key, it's going to like expand to the right of the selection. And then you can like imagine that you have like multiple places selected at the same time, and it's just expanding all those places you have selected. Something like that. Could like in this very simple structure. Just a flatten. I'm going to expand it to an array like this. So we could do something like this. And this should definitely be implemented better, but I'll do that probably off stream. Like, what is the message? Just pop. And then set the selection to the last one. Then we can just right, left, left, right, left. You get the idea. So just need to expand on this kind of idea. Don't make it as hacky as this. And then instead of like having text here and this interface here, you can either work in text, because text works exactly like this. Like just imagine your cursor in text just being this red thing we're just moving with merely hitting left and right. It's the same in text, so each of these points being one of the letters, or if you hold Control and just jump over words, you can like jump to another position quicker. But in this thing, you can't like use your keyboard to work in this interface. So you could imagine that when I have something selected, it could be one of these. And then when I move right, and there are like two options to go, the cursor will just duplicate itself and go in both directions. Things like that. I'm not sure. Maybe I'm not sure whether color or like an extra like this is good. Wait, what am I? I was like, how did I create a space there? Somehow I have managed to. Oh wait, because it's like jumping ahead twice, then I'm moving back twice before like JavaScript is able to like render, because it's asynchronous because of React. So twice to the right, once to the left. No, I need to do it like really fast. There we go. Either way. And then you can have like tensors by just moving up. Just arrow up. Just take the rays. We duplicate them all. I mean, we can just map them. Map them to values. Split into subarays. Why are you complaining? I could just flat map. It works. Let's see. And then a duplication here. But then with the y coordinate changed. So that's I mean, plus we can just be hacky right now. It doesn't really matter. Let's see. It's a good way to do this. And then just do it like this. Put the position at just add a Y to it. Like this will probably work. And I'm not changing my selection here. Let's first see if this works. So it should be duplicating like the entire line. I have like a few options, move up. That didn't work. It did duplicate, but it doesn't move it up. No. That might be why. Sure, start. Right. Up. Up. There you go. Would like add something more here. This, and then a rotation as well. So it like creates a grid pattern. We would need one. Is definitely something like this. So if we move to the right and then up, we just create a grid pattern, if I didn't make a mistake. Grids, more grids. Oh wait, it doesn't expand the grid now. Or it does, but it's just really slow. Really slow. Oh no, it's why is this not working? It should create like more of them. It should be doubling. Doubling. It's probably like overlaying a lot of them. Where is it getting the position from? Each existing array. I think it's doubling them, it's just not displaying them. Then I have like this thing printing out here as well. Why is it not displaying? We can also like move our selection. Selection O. Then just add to the position. This is all like very heavy code still. I'm not sure what the if I could. No. Okay, React is definitely not liking me right now. Move to another tab. Move up. So it should take the red one with it. It did. I don't know if there's something else going very wrong there, but it's at least working. Sort of. Isn't like transfer to skill or something. Oh, this is why. Okay. But at least when my computer isn't like completely lagging and I'm up, like I have it optimized for React or just move away from React, this sort of thing should go a lot faster. Pretty good. Oh, it just breaks down at like the next one. This one just keeps moving up. Nice. Okay. Oh wait, it's like. Well, I will probably. Oh wait, it did expand now. It's just really, really slow. It's probably because of this. Definitely because of this. React is not like made to do this kind of stuff. Okay, I will have to leave now to go out for dinner. I'll probably do some more stuff off stream, and actually implement like this sort of movement for the actual Chyp canvas. Oh, you see, it's still going. It's still very slowly trying to like do times 2, unlike a lot of React components. I'm not sure. I will see how much I can do off stream. But you get the idea from what it's supposed to be. So like this, you should be able to program. You should be able to like automatically compose tensor stuff. We'll see. We'll see where it goes from there. First, I'll just implement Chyp. Then a nice programming interface. We'll see from there. Alrighty. Thanks everyone for watching, because there are definitely some people here, which was a bit unexpected at the end. Apparently just using visual stuff is already like getting more people here. At least for the people who are here, if you just go to the website, you can find more information on the project and the Discord as well. OrbitMines. But yeah, I think I'll leave it there, and hopefully it was. I'll like look at how useful this stream was. This is definitely not what I intend like the main kind of stream to be. Maybe once this interface is actually working, it's more entertaining because it's more unfamiliar to people. But yeah, especially for the first part of this stream, I'm not sure how like useful that was to actually stream it, but we'll see. I'm just trying a few things out. Ready. Thanks everyone, and I'll see you guys later. If I can find there we go.